Hi everyone. In this video, we are going to see about understanding the Spark internals, right? So, as a first step, right, for understanding Spark, it is very critical, right? We understand what is there in the Spark UI, right? What are the things it provides, so that we can do the optimization. So, first level, we will see what are the various tabs available in Spark, and we will deep dive into Spark SQL UI and the explain command, right? So when you create a cluster, you have these seven tabs, right? So number one is configuration. So this is where you will get cluster runtime, what is the cluster, the configuration, and then the JDBC properties, right? And how to connect to this cluster, right? So these things will be there with your configuration. Then notebooks is the place where you attach a notebook, those details will be there. And libraries is the place where you will have additionally installed libraries. So for example, for this demo we are using this library which I will show you later. So this is there. And this is event log is again one key area where we will see when the cluster was started, whether the cluster was healthy, right? Or there any GC issue, right? So in order to check the cluster health, right, or if your queries are running very slow, you can come and check here. And also auto scaling efficiency, you can check here, how many nodes have been added or reduced, right? So you can check here. You have this filters. Since we have a community edition, we don't have the auto scaling these things, but you can see here when it was running, right, when it started running, right, who started it, right, all these things will be there. This will be very critical when you want to see a cost reduction perspective, right, whether auto scaling is used correctly, or whether your disk is getting used correctly, or if there is a heavy spillover, right, you will see expand disk option. So whenever you see an expand disk, you will see, basically that means basically there is a more of spill and your memory is not enough and it is expanding the disk, right? And the spark ui is the key. So this has job stages. Storage will have your storage details, and this will have the cache data which I will show in this demo. And we have the environment. So environment will have your other configuration properties, whatever it is set, right? So if you're coming from a Databricks or a non-Databricks Python or your PySpark on-prem background, whatever you set with Spark config, those things will be present here, right? And then we have the executor tab, which will have the executors and then the driver related configuration. So we have only one active executor is there, and then there is one driver, so which is being shown here. So you have the overall memory, right? So 3 GB is there. We have 8 cores. Yeah, and yeah, that's it on this. And finally, we have your SQL data frame API. So this is where our debugging will come into play, right? Whenever we execute something, this is the easiest tab. You can first check to ensure that whatever we are doing is basically getting if it is getting working correctly or not. That is something we can see here, right? Then we have the JDBC ODBC driver. So this will be helpful when you have say you have a JDBC connection, right? Say you connect from other tools like SQL Alchemy or through some DB Weaver or other SQL workbench, right? So you will get the details here, right? And if you are using streaming, you will get streaming here. And then finally, if you're using Databricks Connect, which is pretty much new, so this kind of allows you to execute arbitrary Spark code from your Python or Go application. So those things will come here, right? And we have the driver log. So driver log is again one more key component where you can see, right, the main reason why we will come to driver log is generally to see how much of GC has occurred, right? So generally GC should typically happen within once in half an hour. If you copy this and search for full GC, if you see it relatively less than half an hour, then there is some memory issue within your cluster. This is one of the indicator for your cluster memory, right? Now we have this background. Let us go and see your data, right? So in this one, what I'm trying to do or what I'm going to do is I will use open source Azure data set. So the link is given here. So this is some open source data set which is basically given by Azure, and you can load the data and we can use it for our demo. So I have taken this piece of code and then written as a function. So we are going to read this data. Yeah. So let us load the data. Okay, and we will do a limit 5, right? So this will just fetch some sample rows from our data set, right? Now once the data is loaded, right, so it is a typical data set of taxi. You will have the vendor id, start time, end time, right, your passenger count, all these things, right? So you can read about this data set in this link, which is attached as part of this notebook. So let's see, right? So these are basically Parquet files. So let's see how Parquet files will be dealt, right? Number one is partition, right? So we might have a question, right? Why do we need a partition, right? Or how does partition matter, right? So for that, if you see this particular folder, you could see this input is again partition by year, and within a year, if I go and filter for a particular year, right? Say 2012, you could see it is again partitioned by month, right? So now let's run a query, right? Before we run a query, let us see this explain command, right? So whenever we run a spark code, we have a couple of options to see how it is working. One is an explain command and another one is through the spark SQL UI. So first we see the explain command, right? So explain command has this signature. So if you can see here, right? So this has two signatures. So one is it has an extended parameter which can be true or false, or we also have other options, right? So if you are kind of a too much of a code level, you need a low level details, right? Sometimes we write our own beauty of those things. Then you can use this code gen, or you can typically use the extended or the formatted, which will give a cleaner output. So now let's run the explain command, right? So this is a normal explain. So this will be kind of clumsy. You won't see like better information. So you can use this extended option. So in this extended, right, you will get a clear version. So it will give you the actual, as you know, right, Spark will internally convert this into plans, right? So you will have the parse logical plan. So in the logical plan, it just verify the column name, and then we have the analyzed logical plan. So where it will verify again, right, or pick up the best plan out of your given set of plans, and finally it will have the optimized logical plan, and then your physicalized plan. In the physical plan is the one where it will give the exact action. So since Parquet is a columnar format, so it will basically first read the data in columnar format, then it will convert to a row format, and that row format it will be displayed. So you can see limit of 10 because I have given a limit 10, right? So the same can be done using a code gen, but code gen will give more of a very detailed output. You can see at each row level, right, on or how it is exactly executing, right? You will see the exact code. So this will be mostly, this might not be needed for unless you are using a very like a third party function or a package and you want to understand the slowness, you can use this. And this formatted will give you a perfect formatted output. So you can see here, right, at each of the step, right? So it is reading the data, it is using a batched read. So it is reading not row by row as a batch. It is using in memory, it is reading this, it is using, it is fetching the particular schema. And then next step is it is basically having this columnar to row. So this will basically convert your column values to your rows, right? Which I will like explain later, right? And we have the collect limit, right? So we are just limiting 10 rows, so that is getting fetched since we are selecting all the columns, right? So this is the one. And now let us see the Spark UI, right? So let me run this command, right? df.count. So this will take some time. Okay. Now we got the output. So if I click on the view, right, so this will go to my stage. So we don't need to explore the stage for now. We will explain or like understand the SQL tab. So you can switch on job IDs, and then this will go to your SQL query. And the key things for you to check here is, right, how does this read, right? So since we have given a count, we will need to scan all the partitions. So if you can see here, number of partitions read, right, you could see it is 161. That is why, because you have year level and then month level, and number of partition columns is 2, which is year and month. And Parquet will internally have something known as row groups. So this is the minimum level of separation. So I will show you these in detail in the upcoming steps, and it will give you the total number of files read and number of columns in the relation, right? But if you clearly see here, the number of scanned columns is 0. That is because we are not scanning any column, we are just taking the count, right? So Spark doesn't scans this one. And you will not have any additional details on cache, because we are not cached anything. And you can also see the same explain plan whatever you saw earlier, right, in the df.explain, the same will be present here, right? And finally we have this cloud request, which will basically say how many requests has been made to the cloud to get these data, right? Now let us do one thing, right? Let's filter by a particular partition and let us do a display. So earlier it was reading all the 160 partitions and it is not scanning any column. That is because we have given a count at the overall level. Now let us see this one. Yeah. Now if we go and see here, you will see, right, number of partitions read, right? You could see it has reduced from basically 160 to 12. Why? Because we are reading a particular year and inside that we have 12 months, right? So that is the thing. And number of files read is 240. Why is it so? Let us see that one. And number of scan columns, since we don't have a count now and we are displaying everything, you will see the scan columns is having a good amount, right? Or it is scanning all the columns, right? So that is where, right, if you select only particular columns, this will also will get reduced, right? And next thing is, we saw the output as 240, right? But why it is 240 is because if you see, right, I have executed this query already. If you see the distinct of files which are present in this particular partition, it is basically 240, right? So the all the files are getting read, so that's why you see that 240 basically, right? Now let us do one thing, let us filter again for a particular month. So since now we have enabled, or we are basically filtering for both month and your year level. So now you could see in the SQL tab, so you could see here clearly that these filters would have been applied. You can see here clearly, right, like number of partitions read is 1 and number of columns is, partition columns are 2 totally. Out of this only one partition is getting read. That is because we gave for a particular month. And the number of files read also, you could see it is getting reduced very well, right? And then, so let's say, right, we basically want to run this query again, right? So it took around 3 seconds, right? And now let us run this query again. So if you see here, right, it is again going and fetching the data from the cloud, right? It is not doing any cache. The same can be how we can verify that is, if you see my explanation earlier, I said under storage tab, right, you will get whatever it is getting stored or whatever it is in the memory. So if you see here, right, clearly nothing is stored in the cache. So especially generally typically you have heard about df.cache or dataframe.cache or persist, right? But that is the old way of doing things, right? Especially for Parquet file format, we have this disk IO cache. So you can just enable this property. So once you enable this property and then run the same query again, right, the very first time you will not see it giving quickly. It will take the similar time, right? So let me go and show you in the UI, right? But one thing would have been clearly changed now. So once the property is enabled, you can see in the associated SQL query, it will be the same plan, but additionally you could see this data return, right? So what it is basically doing is for each of a query which you execute, it will take the corresponding file, right? And this disk IO cache will load your Parquet files in the executor's disk. So that's why it is named as disk IO cache. Whenever you are reading a particular column or a filter or a particular file, right, it will check if it is there in cache. You will see a cache hit ratio, meaning how much of the records, right, it took from the cache, right? And if it is 0%, it means, right, it is not using the cache, right? Now let us run the same query again. And now since it has written something to cache, if you go and check the storage tab, you will clearly see here, right? So it has written this 41 MB, right, corresponding to probably one of the files, right? Now let us do one thing. Let us again, or let us again rerun the same command. Let me run again the same command. Right, I will run again in the same UI. So now you should see it significantly. See, now from 3 seconds it came to less than like around 1 second, right? Around 60% of this time it has reduced. The trick here is nothing but your disk cache has been used. It does not make a request to the cloud. So if we go and see the associated SQL now, so you will see certain, how you can verify that if it is coming from cache is basically you could see it, right, partially taking it from the cache, right? This is because probably you have multiple files, and for certain records, right, it was able to take from the cache. So you can see around 720 KB it has taken from cache, and the remaining for the missed data it has written, or it has written back to the cache. So say we have three files there, right? So maybe one or two files it would have read randomly. So for the other one, right, it would have added now, right? So this is how this cache work. And you can avoid data frame.cache or data frame.persist, because those things are not an optimized way, or that will keep on memory, or even if it is keeping on the executor, it doesn't keeps on a more optimized way. This Parquet cache is a optimized Parquet format which is written by Databricks of late. So this is the way going forward you can cache the data frame. And with this approach, right, you don't want to cache for a specific column. It will cache all the files, so it will benefit all your queries, whatever you are running for a table, irrespective of your particular select. Right, just a property enablement at cluster level will save you a lot of cost if say same set of tables are used by multiple team members. And next thing is, I have just added for another one filter as well, but I think I have shown. So the interesting thing here is, right, the row group point, right? So we basically in Parquet, row group is the key. So let us like run this first this one, where I did not specify any column. I'm just specifying a partition. So it should basically go and fetch all the data which is in year 2012 and in month 4, right? So now if we go and check the UI, okay, you will see, since this 4 is not already fetched, right, you will see, right, the cache mesh, see, there is nothing read from cache, because for partition our month equal to 3 alone we have already cached, so nothing has been cached now. So you will see here, right, it would have fetched one partition. Where is it? One partition it has read, and it has fetching all the row groups, right? So the more the row groups we fetch, that means we are again not effectively having the partition data, right? Or internally when Parquet has the data read, it will fetch by block, right? One block is 128 MB of size. So each Parquet row group which is less than 128 MB, it will be read with one partition, right? Now, this has read all the 107 row groups which are present in the file, right? Now, how can we confirm that? So let me run one more query, and I will also get the file name here, right? So this will also fetch all the 107 partitions, right? Or to narrow down, the idea of executing this query is, right? See, when you filter for equal to CMT, it should only fetch the row groups or read the row groups which are having that particular value CMT, right? So to better explain this, let me go and show you the internal structure of Parquet, right? Say this is how Parquet stores the data. So you have a Parquet file. Each Parquet file will be separated into row group. So each at a Parquet file, at the end of the file, right, you will have the stats about the row group. Say for example, how many row groups are there, and each row group will have a certain number of records. Say for example, 5 records here will correspond to a row group, and each row group will have say 5 rows, right? What will happen is this column chunk, right, say 101 to 105, right, this will be written one after another in the disk. So when we fetch the data based on our filter, right, it should narrow down to the particular row group. So how does we get the optimization in columnar format is, this is the trick. So you have the stats collected at two levels. One is at file level. So at file level, it will store the row group metadata, right? So for inspecting this, right, see, theoretically this will be little difficult. So we have this particular library. So this library, right, the details can be found in this source, right? So if I'll just click here, I'll add this notebook in my GitHub so that you can go and check. So this library has all these internals, right? So let us do one thing, right? Let us take this input file and let us try to understand, right, why it has read all the 107 row groups, right? So first step is we are reading the Parquet, right? So once you read a Parquet, we have a metadata at the footer level, I said, right? So this will give you the footer level metadata. So for this file name, there are 107 blocks or row groups, right? And this is the compressed bytes, this is the uncompressed bytes there, and this is your number of rows, right? And then who created this, right? What is the schema of the file, right? Now let's see, we want to get the stats at the row group also, right? I said one place it will store at the footer. This footer will basically have, I mean, this will give you the metadata of how many blocks are there, right? But we need to know each block, right, where it starts and where it ends, right? So this will be the second filtering. So this is the row group part, right? So you have a row group. So each row group will start at this, right? Since you know the position, when you do a filtering, right, when it fetches the data, it will only go and fetch these particular groups alone. For example, if it knows the min and max values, right, so this row group again, what it will contain is, it will contain the min and max values. So when I again read this row group, right, so if you see here, this file is having 107 row group, and each row group, right, has the column stats. Say for example, right, row group 1 will have column enter ID, the min and the min and max value will be there. So this is what it will be leveraged to filter, right? So, and apart from that, there are optimized encoding, right? Say bit packed plain dictionary. So what this means is, Say you have a column male or female, right? Instead of storing male and female n number of times, it will have a dictionary. So what it will do is it will keep m as 1 and female as 2, right? And it will just store 1 and 2 in the data so that it can save the 4 character space. Right now, if you store as male female 100 times, you will have, say, 100, approximately, right, 400 characters you have to store. But if you store it as only one, then for a male 100, you will just have to store 100 characters, right? So those kind of compressions will also be done to efficiently reduce the size. So that details will be given in this one, right? Now we have the min and max value, right? So why did it read all the 107 row groups for us, right? So for understanding it, let us see the vendor id. Right, what I'm doing here is I'm reading the same array column, right? And I'm checking wherever the vendor id columns are there. So in each row group, if you see here, for each of the row group, it is clearly giving you, for row group 1, for column vendor id, what is the min value and max value which is there, right? So this is how it will internally go and filter. So what I'm doing is, for this column vendor id, if I filter, you could see here, right, it is present in all 107 rows. That means when you filter this data, it is going to fetch all the row groups, right? Meaning it will read all the entire file, right? Which is of no use for us, right? So let's take another one column, right? I have just taken passenger count. So if I go and filter for passenger count, and when I take passenger count, right, I have taken for passenger count, I am just taking a rare value, right, a max value of 9, right? If I go and check filter, and then if I put value of 9, right, so this 9, right, it is present only in one of the row group, right? So what it will do is, so let's say, right, when we filter the data for this row group or for this record, so it doesn't need to read the all the entire content into memory, right? It will just fetch the file, and within the file, since we are only filtering for 9, when it loads the data in memory, right, it will read only the required row group, right? In this case, it is just one single group. Let us see that. So if you come and see here, now you will see number of row groups read. Where is it? Number of scanned column, number of partition columns. Yeah. So number of row groups read, right? It has only read 5 groups. Why that is it? Because see, it will go and fetch, right, for each of the row group, right? It was trying to get the records, right? So by the time it identifies, right, in which one it is having that passenger count 9, right? So only those row groups will, say, once it gets the value, right, where row group is having a value of 9, it will stop there. So now you could clearly see it doesn't read the entire row group, so it is just fetching only one block of data, right? So that's it. So to conclude, let me go through again from top. We saw what are all the various UIs are there, and what are the various layers are there, and how to load the data. How does partitioning affect, right? Or how does partitioning does the benefit, and how does explain command works. Then we saw how does enabling caching, right, will reduce your overall time because it doesn't have to make a cloud request. It will take the minimum amount of data whatever it is there from cache, and the remaining will be cached again. So this will be very beneficial if you are doing a query again and again. And then finally, we saw about Parquet internals, right? So Parquet is a columnar format. So each Parquet file has a footer. That means nothing but the end of the file. At the end of the file, you will have metadata regarding your row groups, right? So the row group is nothing but block. So this data will be there in your Parquet file footer. Say this will give you each how many row groups are there, and each row group start at which point and it ends at where, right? And once we have this row group, then what it will do is it will basically have a row group will again have a stats. So that stat will give you the min and max values which are stored in each row group, right? So finally, when we filter for a column, it will navigate like this. It will go and first fetch all the given row groups, and then it will fetch each of the row group and see the condition satisfying the criteria, and it will read only those row groups which are matching the criteria. So that is also confirmed by this one. When we made a passenger count equal to 9, right, it has only scanned up to 5 blocks, right? So this is where the optimization techniques like z order, right, which will co-locate your column values in a single row group or a less number of row groups, thereby ensuring a quicker data read. That's all I had for this video. Please do like and subscribe, and I there will be much more coming on optimization piece in the next upcoming weeks on adaptive query execution and then how shuffling works. So do subscribe and share with your friends. Have a great day.